For the last 2 months, I've been on a mission to improve my CAD skills, level up my projects, and unlock the true potential of my 3D printers. And let me tell you, I've learned a lot along the way, including about a dozen really valuable skills, shortcuts, and mindset adjustments that I'm really looking forward to sharing with all of you in this video. See, like most of you, I knew how to design simple parts or even moderate assemblies, but there was still this huge gap between my ideas and my ability to execute on those ideas. And while I love that there are millions of incredible projects out there for me to download and print, at some point, I just got tired of hoping that someone else would solve my problems. But throughout this entire challenge, there was one lingering question in the back of my mind. Could I really get to a point where I could design anything that I wanted to? Or would I always just be limited? There was really only one way to find out. Let's get after it. The challenge started on day one, not by hopping into CAD or even with an online course, but actually by journaling. See, I used to teach learning and memory techniques, so I know all too well that one of the most important and overlooked steps in any learning journey is just to sit down and define what success actually looks like. What do you actually want to achieve in concrete terms? So in the case of CAD, do you want to get better at organic modeling or parametric? Are you interested in modifying other people's designs or creating simple one-part wonders or designing complex mechanical assemblies? Coming into this, I thought that I was pretty proficient at designing parts. More on that in a few minutes. But I had no idea how to properly create more complex projects. So that was going to be my focus. But that's me. What about you? Before we get into the more practical tips, I want you to take a moment and share what aspect of CAD or design you want to get better at down in the comments below. Hopefully, it's something that I'm going to cover in the next 9 strategies, but if not, the exercise will be really beneficial for you, and it'll help me plan a potential follow-up video to this one. Now that we know what we want to accomplish, the next important step is obviously going to be choosing a CAD package that supports that goal, not just the CAD package that everyone else seems to use. If, for example, you're really into mesh modeling or sculpting, you'll probably want to choose Blender or Shaper 3D. If, on the other hand, you're into parametric modeling, then you're going to want to choose another option entirely. Now, I know that many of you probably already have your CAD software of choice, so I won't harp on this point, but I will just say that if you don't absolutely love the CAD software that you're currently using, or you're finding a lot of friction when trying to do the things that you want to do, switch. I spent way too long trying to adapt Blender to meet my needs, and in the end, things really turned around for me when I found the right software for the type of design that I wanted to do. In my case, it was Onshape, which I'll tell you about a little bit later in the sponsored segment of this video. But for you, it might be something else. The bottom line is the right CAD package depends on what you want to design, what type of computing device that you want to do it on, and how you think. So I just can't stress this point enough. Find a package that works for you. Like I said before, and like many of you, my big goal with this challenge was just to become more proficient in designing more complex assemblies or projects that use lots of parts. So it should come as no surprise that that's exactly where I began my learning. Now, before, if I wanted to design a project, I would just jump in and begin designing each individual part in place until I was done. I thought that assemblies were only for when you needed to add hardware or create interactions between the different parts. But I was wrong. The problem with putting all of your eggs in one basket in this way is that your feature list gets really, really bloated. And even with the tricks that I'm going to teach you in just a second for organizing them, it's still a lot to scroll through. So as I watched different training videos and recommendations from CAD professionals, I came to realize that there's a much better way to do it. Basically, if certain parts rely closely on the same geometry or use the same sketches or Boolean from one another, then it's fine to do it that way. Design them in one workspace. But as soon as you start getting more complicated with parts that aren't geometrically related, you really want to start designing them in separate workspaces or part studios, and then putting together the entire thing, hardware and all, in an assembly. Then, if you need to reference another part for a part design, you still can by pulling in the part or assembly, Onshape calls this the derived feature, into the new workspace or part studio. Now I'm saying Part Studio because that is what it's called in Onshape, but the same principles and best practices apply to whatever CAD suite you're using. Actually, hang on. Hey, ChatGPT, can you do me a favor and translate what I just said into Fusion speak?
Hey there, Fusion users. Think of this like using multiple bodies in a component versus a top-level assembly with joints.
Ugh, no offense, but even the terminology in Fusion really turns me off. Like, bodies? In any case, this one habit, alongside a few of the other tricks I'm going to share, will massively clean up your feature list, making it so much easier to go back and tweak or edit your designs, which saves you a ton of time. Now, I'll admit, I don't always take the time to do this, but when I do, it really lowers my sense of overwhelm and clutter. And that's a good segue into the next two things that I learned. Okay, so maybe this next one isn't as much of a tip as a mindset adjustment, but it was a big enough of a revelation that I just had to share it with you guys. You see, going into this, I had a lot of feelings of embarrassment at how long it would take me to design seemingly simple assemblies, which discouraged me from trying to make progressively more complex things. But then, just by virtue of documenting this journey, I realized two things. First, when I looked at the time lapses that I recorded for this video, my designs actually weren't taking nearly as long as I thought they were. It's just that when you're in the flow state, you actually lose track of time. Second, because of that, I started asking other designers that I respect how long it took them to design their projects, and the answers, often weeks or months of full-time work, totally blew me away. This stuff takes a lot of time, but because it's not exactly entertaining to watch someone sitting at their desk in CAD for 4 hours, most YouTubers downplay or completely omit the amount of time that it actually took to come up with their designs. And actually, when I watched some of the speed CAD tutorials on my friend Too Tall Toby's website, I sometimes found myself coming up with even faster or more efficient ways of doing things than even the absolute pros did. What I'm trying to say is, don't get caught up in thinking that you're slow or inefficient like I did, because A, you don't have a good sense of time when you're really focused, and B, design work just takes longer than most portrayals online would lead you to believe. With that said, once I got the big structural stuff handled, assemblies, design flow, mindset, the rest came down to efficiency, and I had a lot to learn on that front. Probably the biggest takeaway from this entire journey was just how much you can compress the design process using simple shortcuts rather than mousing around your CAD workspace, and how that efficiency then has compound effects down the line. For example, sure, a shortcut like the customizable S-Quick menu instead of searching for a specific function, or hitting the space key instead of deselecting things one at a time, those might only save you like 2 seconds each. But when you do each of those many thousands of times throughout a project, it quickly adds up to literal hours. And that's just the beginning. How about memorizing the shortcuts to hide sketches, change views, create sketches, choose different tools, or select hidden objects rather than mousing around, hiding individual parts, selecting the part that you want, then unhiding the parts. I'm not exaggerating when I say that these tips alone can literally double your efficiency, shaving off hours while helping you maintain your focus. But that's just the start of the compound effects, because when certain features become faster and easier to access, it actually becomes easier to abide by best practices. Take, for example, hitting Shift-N to rename a sketch or a part, as opposed to mousing over, double-clicking, and mousing up to click Edit. That saves a lot of friction, which makes it much more likely that you'll actually do it. And that has compound effects when you actually take the time to name everything. See, in most CAD suites, you can not only name parts, but also sketches, features, the works. And while this is an extra step, even with the keyboard shortcut, it more than makes up for it in time saved. How many times have you had to go back and modify something in your design after printing it, only to forget where exactly that feature was defined? And that problem doesn't get better with time if you're coming back to the project months later to improve your design. By naming everything, you save tons of time hunting around for the right sketch, extrude, or fillet. Plus, you make it much, much easier for others to remix or collaborate with you down the line. But there is yet another, even more efficient way to modify your designs, and that's variables, or parameters for you Fusion folks. Sure, if your sketches and features are properly named, it's pretty quick to get in there in any parametric modeling software and change certain parameters. But if you still have to mouse around and go into the sketch and find the right parameters, double click, and all that different stuff, it's a lot of friction. If, however, you use variables, you don't even need to go into those sketches. And if you reuse the same variables over and over, for example, in a shared variables studio throughout the project, you can fix entire projects with just a few keystrokes. Not sure how precise someone's printer will be? Declare a variable for clearances. Need to make different versions of your designs for use with different hardware? Declare variables. Unsure just how big you want something to come out? You get the idea. Variables make it quick and easy to modify entire projects, so long as you plan ahead in your sketches and design accordingly. You do need to make sure that you're doing things like extruding to specific faces or vertices rather than blind, for example, or you will end up breaking things down the line. So as you design, it's a really good idea to fiddle with your variables just to make sure that your design doesn't break when those variables are actually manipulated. But in case you do break things when fiddling around with your designs, and you probably will, now is a good time to remind you another one of those best practices, and that's versioning and branches. Personally, for example, I knew that I could create different versions of my designs or branch them off into different designs with a common ancestor, but I actually had no idea that I could go back in time and retroactively declare different places as versions if I forgot to do it. Creating versions, like the last few tips, is a best practice for a reason. If you ever screw things up, it gives you a quick point to restore back to without having to waste minutes or hours trying to figure out where everything went wrong. What's more, it's another one of those things that makes it much easier to collaborate with other designers, whether in a professional environment or just when you share your designs with other members of the 3D printing community. Actually, on that note, I have to make two quick announcements, both of which involve you getting a massive amount of value for free. First, the folks over at Elegoo heard that I was doing this video, and they asked that I let you guys know that they are giving away $1 million in cold hard cash to designers who upload their designs to their new file sharing platform, Nextprint. Now, if that doesn't motivate you to improve your CAD skills, then I honestly don't know what will. And second, if you're not sure which CAD program to use, or you're not 100% happy with the one that you're currently using, then I'd like to recommend Onshape, who, as you might remember, is the sponsor of this video, but even if they weren't, they'd still be my personal CAD software of choice for a few different reasons. First of all, I've tried a bunch of different design softwares over the years, and Onshape is consistently the only one where the workflow actually feels intuitive. I also love how Onshape works smoothly across all my devices, both desktop and mobile, and just how quickly and easily I can collaborate with others, just like when I'm working in Google Docs. But beyond that, I love the powerful stuff that's built right on top of it. Things like FeatureScripts and parts libraries, which we'll cover in just a few minutes. But Onshape isn't just for hobbyists. It's a professional-grade CAD and PDM suite. Hey, me again. What is a PDM suite?
Hey again, PDM Suite is just a whole package of tools to manage your design data. It's like having a full toolkit to keep all your project files organized.
Sign up for free using the link in the description, and if you are an engineer, A, please don't make fun of my CAD skills in the comments. And B, you can get up to 6 months of Pro, which is a $1,250 value for free. Now let's get back to the video. With the last few tips, your timeline will hopefully be much cleaner and more intelligible than ever before. But still, there's something to be said for having fewer features, both for the sake of efficiency and for legibility. That's why this next tip has been so transformative for me. Basically, it's to invest some time in learning about the lesser known, or what I'll just call as-you-go features of your CAD suite. I'll explain what I mean by that in just a second, but I really don't want to make this video specific to any one CAD suite. I do, however, need to give examples, so forgive me if this one is a little Onshape specific. One example of what I'm trying to say here would be the ability in Onshape to draft and extrude right as you go. Rather than using the draft feature after the fact, which means additional clicks and another feature clogging up your timeline, many times you can just draft right from within the extrude dialog. Another similar example would be the offset feature right within the Boolean command, which, by the way, you can double up with tip number 7 to really maximize efficiency and declare all those different clearances as one variable. But there are lots of additional examples. I, for example, used to always manually draw or offset lines whenever I needed a slot, until I realized that there was actually a slot feature right within Onshape. I used to always create an offset plane if I needed to split an object, till I realized that you can actually use any face to split another object. And the list goes on and on and on, and it will vary from software to software, so my recommendation would just be to spend some time studying these features. You could go through the menu bar on your CAD suite of choice and Google search any features that you don't already understand, or check out some of the tutorials and videos online from folks like Too Tall Toby to see which features others are using in their design process and how. I've actually spent a lot of time doing this recently, and I'm constantly learning or remembering different lesser known features as a result, and those are making me so much more efficient. And that's probably a good time to mention another lesson, which is that in most modern CAD suites, there are actually many ways to do the same thing. And as I mentioned before, some ways, like so-called as-you-go features or dedicated features for things like the whole function in Onshape, are going to be faster and more efficient. And it's definitely worth learning those faster features. But other times, there may be multiple perfectly good ways of doing something. Say, the difference between sketch fillets and part fillets, or creating patterns within your sketch versus patterning a feature after the extrude. Heck, sometimes there are entirely different methods or workflows to go about creating the same geometry. I say this because for all my talk about the merits of investing in efficiency, at the end of the day, as my dad always loved to say, the fastest way is the way I know best. I mean, sure, it might be more efficient to model something with a revolve, but if you're more comfortable or efficient with a series of lofts, for example, then there's nothing wrong with doing things the way that you prefer. So don't waste time beating yourself up about not doing things the ultimate perfect way. Another way you can really improve your efficiency, especially when it comes to more complex assemblies, is by using parts libraries. I'm a bit embarrassed to admit this, but I actually used to think that if I wanted to use, say, an M3x8 bolt in my design, I first had to download it from a site like GrabCAD and then import it into the project for use in an assembly. Yeah, I know. It was only by watching tutorials on Onshape's website that I realized that most professional CAD suites actually already have an entire library of all the standard hardware that you would ever want to use. Not only that, but in Onshape, you can even import components or entire assemblies from any of the bajillion other public designs that other people have already uploaded and published. But it gets better because in many of these CAD suites, you can actually create your own libraries of parts so that you have everything that you frequently use at your fingertips. Say, for example, you are a multi-board addict like me. You can create your own library of common hardware, allowing you to instantly import those pieces into your assemblies or future designs and right away integrate them into your parts. Just a side note though, you should only ever do this for private personal use if you are uploading other people's designs, because you might technically be violating the license of someone else's designs by distributing their work if you make it public. In any case, this saves so much time, and I cannot believe I didn't know that this was a thing. But what about libraries of parts that are just too extensive, too varied, or too customized to be listed comprehensively? For example, there are a million different types of configurations for Gridfinity bins and bases, and nobody out there is going to upload a library all the way up to M85 bolts or threads. So for that, we have FeatureScripts, or add-ins as they're called in some other CAD suites. Now, FeatureScripts are basically apps or plugins that other developers have made to extend the functionality of your CAD package. In Onshape, for example, you have FeatureScripts for texturing an object, inserting custom Gridfinity bins into your projects, creating custom threads, and a whole lot more. But there are similar add-ins for other CAD softwares as well. Now, leveraging these plugins saves you a ton of time because it allows you to quickly insert functionality into your projects that could take hours if you had to manually design it, all with just a few clicks. And it can really level up your designs as well. So whatever your CAD package of choice is, I highly recommend searching around and installing some of the most popular add-ons and spending some time figuring out how to properly use those add-ons. Now, another mindset thing that I've had to really make an effort to change has been around prototypes. See, in most other maker endeavors, whether it's building a 3D printer or building a custom wooden workbench, you generally do everything in your power to get it right the first time. I mean, measure twice, cut once, you know? So when it came to design, I found that I was actually holding myself to an impossibly high standard and beating myself up when my first prototype didn't fit properly. But the truth is, no matter how good you get at simulating your project using assemblies, there are always going to be unknowns when it comes to designing something new. It could be something like clearances or tolerances that need adjustment. It could be mechanisms that just don't work the way you envisioned they would, or just something not looking or feeling right in the real world when you hold it in your hand. And here's the thing, if you expect yourself to get it right the first time, you'll always have a negative association with designing new stuff. At least that's where I was. So instead, I'm trying to teach myself to take an approach that's more in line with how software startups work, to embrace failure, but to fail faster and learn as much as I can in the process. After all, we do learn more from mistakes than we do from success, and most mistakes in life cost a whole lot more than a few bucks worth of wasted filament. So now, when I design something, I do a few things differently. First, if it is something big, I see if I can isolate the unknown parts like hinges or mechanisms and test print just those pieces. Now, your slicer's cut function is actually really great for doing that. And second, instead of reprinting prototypes that don't fit, I physically cut or shave, melt, or glue, and just otherwise massage them into a new prototype to see what will work before updating my design and printing it again. This way, I can effectively cut in half the amount of wasted time and material I use in my design process, and that reduces that guilt just a little bit. And third, I try to remind myself that prototyping is a natural and expected part of the design process. I mean, companies like Recycling Fabrique have built an entire business out of recycling the prototype 3D prints from just Germany's largest and most respected manufacturers. So if the pros at companies like Bosch and Siemens and BMW need to print out a few prototypes before they get it right, then you better believe that amateurs like myself do as well. Which brings me back to the question that I asked at the beginning of this video. After 60 days of immersing myself in all things CAD, where do I stand? How much better did I actually get? And have I overcome some of the limitations and hurdles that were holding me back? Well, as of right now, I'm probably not going to get any job offers from SpaceX anytime soon. But I do think that I've turned a corner. See, at the end of the day, it all comes down to confidence. If I've learned anything, it's that complex designs take a lot of time and a lot of work. But before this challenge, I didn't have the confidence to even bite off those bigger projects. So I didn't. But over time, both through creating progressively more complex designs myself or just by observing others, I've really come to realize that the only things separating me from them are actually experience and the confidence to actually sit down, put in the hours, and gain that experience. No, 60 days didn't turn me into a trained engineer. I still don't know the design principles behind why you use a specific kind of bearing or a certain size gear or anything like that. But for the first time ever, I'm confident that if I just keep going, keep designing new things, keep learning new techniques, eventually I'll get there. And I bet you will too. That's all for this week, but I'll see all of you on the next layer.